This is Trig Identities, part number 21. So how does Ptolemy's theorem help us prove the sign of A plus B? Okay, let me show you the illustration here. Now this illustration looks virtually identical to the illustration we had in the last proof, except for one thing. There's one major difference. Line BC is now the diameter of this circle. I know it doesn't look that way, but that's exactly what it is. Okay? And because it's the diameter, it also passes through the center of the circle, which is going to be very, very important. Okay, now we're going to make the length of BC equal 1. 1 what? Doesn't matter. It's going to be 1 of something. Alright, as you can see here, we have angle A and angle B. Now what we want to find is the sine of the sum of A and B. Alright, that means that you have to add the number of degrees in A to the number of degrees in B, then try to find the sine of it. Okay, so it's not the sine of A, then the sine of B. It's the sine of these two angles combined. Alright, and believe me, there is a giant difference between finding the sine of A, finding the sine of B, and then adding those numbers together, and then trying to find the sine of A plus B. Giant difference. You'll see later on. Okay, now, let's get on to this. Alright, now how are we going to find the sine of A plus B? Well, this is going to form one giant angle. As you can see here, this triangle is not a right triangle. It's not isosceles. It's not equilateral. It's just a regular, ordinary triangle. Alright, but we can still use the law of sines to find the sine of A plus B. How do we do that? Because what we're going to do is we're going to find the sine of this line right here. So that means we're going to have to know the length of this line. How are we going to find the length of this line? Through Ptolemy's theorem. Okay? Now how are we going to do that? Well, first of all, you have to realize that this triangle right here, which is B, A, and C right here, when you draw this on the diameter of the circle, it automatically is a right triangle. Automatically. The same thing is true with BDC. This is a right triangle. This is right, this is right. Knowing this, what you can do is you can find the sine of A. That means you'll find the length of this line. Then you can find the sine of B, which means you'll find the length of this line. Then you can find the cosine of A, which is the length of this line, because this line, this hypotenuse here, this line is the longest line, so it's the hypotenuse. So now you can find the length of this line. That would be the cosine there. You can use the cosine of B to find the length of this line right here. Why is that important? Alright, if you multiply the length of AC times the length of BD, you'll get a value. So you take this length times this length, you get a value, you set it to the side. Then you multiply the length of AB, which is this one right here, and DC, which is the length right here. You multiply those two together, and then you take the total of the first and add it to the total of the second, and that becomes the length of this line right here. You say, well, wait a minute. According to Ptolemy's theorem, it's the length of this times the length of this. Well, the length of this is 1. So if the length of this is 1, then whatever this length is, we multiply it times 1 and we get the same answer. So literally it's going to be the length of this. That's how that works. Now then, you say, well, how do we turn this into the sine of A plus B? Because we have this great big formula that comes out. We saw that in the last, well, not the last video, but a few videos back. We saw that. Alright, what is AC? AC is the cosine no, I'm sorry. AC is the I keep trying to say it that way. AC is the sine of A. BD is the cosine of B. So you're going to multiply the sine of A times the cosine of B. And then AB is the cosine of A, and DC is the sine of B. So now you're going to multiply these two together. And after you multiply these two together and these two together and add them together after that, then you get this. Okay? And I was just using these two triangles here as an illustration that this triangle here is a 90 degree, and so is that. That was my illustration there. Okay, so that's how that works. So, using Ptolemy's theorem, we can show you the sine of A plus B. Now, in my next video, I'm going to show you the sine of A minus B. And you could use Ptolemy's theorem to do it, but that's very complicated, very long, and it can be kind of confusing. So, we'll just use something a little simpler for the next video. Alright, I will tell you more in a future video. Stay tuned.